So today we're going to be solving systems of equations that have no solutions and infinitely many solutions using algebra. Now, we've already done this using graphing. And if you want to see how to tell if a system of equations has no solutions or infinitely many solutions by graphing, check out the link in the description below. Okay? But for today, we're actually going to solve this using algebra. So let's go through it. For the first one, we've got y equals 4x minus 3 and 8x minus 2y equals 6. So since all of this stuff equals y, we are going to substitute it in for y in the second equation. So I end up getting 8x minus, instead of 2 times y, it's going to be 2 times everything that y equals 6. All right, so all I did was substitute everything that y equals in for y. Now, I'll use my distributive property to simplify this equation. The 8x drops down, but negative 2 times 4x is negative 8x. And negative 2 times negative 3 is positive 6. All right. And I've got x's on the same side of the equal sign, so I'm going to combine our like terms here. 8x's minus 8x's is no x's, is nothing. Okay. So all that's left on this side is 6. I'll drop my equal sign down, and I'll drop the other side down. And notice what happens. After simplifying that equation, I end up with an equation with no x's, but a statement that says 6 equals 6, which it does. So what does that tell me? Well, since there's no x's in here, and it comes up with a true statement, because 6 is always equal to 6, this tells me that there are infinitely many solutions. Many solutions. All right. In other words, any combination of x and y that works for the first equation will automatically work for the second one. So if you imagine this as a graph, there isn't just one point of intersection with these two lines. The two lines are actually on top of one another. They intersect at every single point on the lines. So there are infinitely many solutions to this. All right, let's look at the second example now. So we've got y equals 6x plus 8 and 18x minus 3y equals 16. So again, I'm going to take all the stuff that y is equal to and substitute it in for the y in the second equation. And I'm going to get 18x minus 3 times, instead of y, all the stuff that y is equal to equals 16. All right. Now, simplify using the distributive property. So my 18x drops down, but negative 3 times 6x is negative 18x. And negative 3 times 8 is negative 24. Drop down my equals 16. Now, just like before, we've got x's on the same side, so we're going to combine our like terms, and look what happens. 18x's minus 18x's is nothing, is 0, no x's. So all that's left over on the left side is negative 24. All that's left on the right side is 16. So we have an equation now with no x's, but this time we have a false statement. Negative 24 does not equal 16. Negative 24 can never equal 16. This is an impossible situation. So what that tells us is there is no solution. Meaning, there is no combination of x and y that would work for the first equation and also work for the second equation. There is no common solution to these. That's why we say there's no solution. So if we imagine this as a graph for these two lines, they would never intersect. There's no solution to it. All right? So that's the key to solving systems of equations that either have infinitely many solutions and no solutions. If you simplify it and get to a point where there's no x in the equation, then you can tell if there's infinitely many solutions and no solutions, because either it'll make a true statement with no x's, or it will make an untrue statement with no x's. All right, so I hope you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.